by CNCG Gandhinagar. So the first session was on Kubernetes and it went very well. People have loved and also learned what are the basic components of Kubernetes. And hope you have seen all the components visually. And we have Arpit who has contributed to a lot of open source projects around security, around DevOps space in Falco, and have worked around a lot of things around containerization. So let's welcome him and give him the stage and let's go on for the boot camp second sessions. Yeah, hi Arpit, welcome here.
Yeah. Hi, Neil. Welcome, everyone. So, yeah, as Neil said, so this will be I think it's the second this thing session
Hmm.
on the
Yeah.
KCNA bootcamp that we had with CNCG Gandhi Nagar, and today I'll be giving you a nice brief over orchestration with some very popular tool which is Kubernetes, and there are other tools as well for which are doing container orchestration. Firstly, it was with Docker Swarm, but it is not used that much. But after Docker Compose, Docker Swarm has been a major, you can say, mainstay for having an overlay network and uh, having orchestration with Docker Swarm. And I'll compare like what were the differences why Docker Swarm was uh, it was not you can say that it's not actually give you that kind of a support in production and why Kubernetes take over. For that I'll share the screen, just a nice PPT. And it's is my screen visible?
Yes, yes, visible, yeah.
Yeah. So I'll be giving you a nice first of all I mean I'm as an introduction to myself, I've been contributing for a lot of projects and mainly CNCF, you can say incubated project like Falco. I have been practicing DevSecOps since last 3 to 4 years, and I work for a couple of cool products in healthcare like Apollo 24/7. I've been part of Master, very prominent in Dubai, and I work for Mercedes-Benz and Ericsson as well. And in all these I mean products, and mostly I have been associated with containerized workloads using Docker heavily, Containerd and Kubernetes. And this has been a lot of roller coaster ride for me in cloud and DevOps. And earlier, when we know that how virtualization was there, and how why container came in, and what's basically containers. I mean, in the first of the session, uh, it was covered or not. I'm not aware of this, but yeah, let's give a nice introduction just to lay a foundation for this containerization and why it came into the picture. So earlier there was, as we know that we had VMs and we had virtualization and we had the concept of VMs and why they came, because we wanted to have the base and also the environment to run various applications. And on top of a host, one host, we wanted to have other separate or isolated environments, and that's how virtualization came in. And we know about hypervisors in Windows and KVMs like virtual machines in Linux, and that's how the concept of virtualization and creating various isolated environments came in. Then came the LXD and you can say Linux containers basically, and that's how it's a property of Linux by which you use namespaces and control groups, and you have namespace based isolations for various you can say dependencies, libraries, and everything that you require to run an application, and you package it in a particular image that you call. And that's how everybody knows that how I mean, you are. attending the second session. So I assume that you are pretty well aware of that, how a Docker image is created and how to create a Docker image out of a blueprint called Docker file. The thing is, when you create a, let's say, a container based application and you wrap in a particular image and you create a Docker container, let's say, for any kind of a application, for it has a wide nature of applications can run. It can be a backend app, it can be a database like MySQL or any kind of thing that you can run on virtual machine. You will pretty much find a nice support for Docker as well. And various organizations like, for example, Jenkins as a tool, you can also run it on Docker, you can run it on Kubernetes, and various other anything that you imagine so far, it can pretty well run in a containerized format. And even today, the AI workloads also are able to run on containers. So when this age came in, when it became really, when the Docker is really became a natural go tool for every for each and every developer, because it is very easy. We don't have dependency matrix issues here. When I say dependency matrix, normal problem like this application runs on my machine, but it is not running in the other's machine. So that kind of platform related issues when they started coming in, so containerization became a go-to tool. And anybody who write the application and ship it, they do it with some Docker image via this, and they do not even require any dependency or anything like that. You just need to install some Docker engine or anything like Podman or Rancher, if you're using anything as an engine for have your container, you can say, a runtime basically. When you have this, you will see that the moment your application stack grows, for example, let's say your application is very complex, I'll bring in the concept of Docker Compose. Uh, we know that what is a Docker Compose. Let's say you have a whole instance of an application, and that instance of an application has various other components. For example, database. You may have a Python API. You may have a Spring Boot API, and like these, you have 8 to 9, let's say, containers, and it can be more based on the how it was written and what was the architecture of the application that you have. You will see as a number of container grows, the overhead to manage the application or see the traffic and the high availability and all those kind of things, you will see that the complexity grows. And when you see in a production format, then this doesn't work anymore. You will never, I mean, hardly you will see that some on a production level things, Docker Compose kind of an application is running on a server, and it is actually serving to a large number of clients or large number of users for this kind of an application. And that's how the need of, when there are 10 or 50 containers, then you will see that they maybe you will be able to manage it manually or doing all this kind of things. Maybe on a particular server, if you introduce something called nginx or as a load balancer, then also it will work fine. But what if your application is handling 100 to 500 or even thousands of containers? Then it really becomes really problematic to manage those containers without having an orchestration format. When we say container orchestration, this is what it means. Orchestration means to manage the whole life cycle of containers, starting from its creation to its running to its even you can say a graceful shutdown when it is not required, scaling, horizontal scaling or vertical scaling, everything is considered into it. When we come to container orchestration, then we had from Docker, we had Docker Swarm, which kind of a similar like Kubernetes. It also works on the format of overlay networks where you have a cluster and you have various nodes, and one is a master and one is a slave, you can say, or a worker, and they all create a whole cluster in itself. But it had some you can say shortcomings. For example, there was nothing called like horizontal pod autoscaler, or these kind of objects or facilities were not there in Docker Swarm, so that's it doesn't pick up in those kind of scenarios. But the moment Kubernetes came in, I mean, Kubernetes is a brainchild of Google Bot, In 14, it got open source and then came under Linux Foundation, and then CNCF got created, and the Kubernetes as a project incubated, and then it graduated also. It is one of the largest supporting open source community, which is today they are contributing to Kubernetes. And that's how the power of orchestration comes here. When you see how it actually your under orchestration, how your container management is automated. For example, the when you might have seen, like in a environment called Kubernetes, when you create a new application comes in, you write a manifest, and you can also mention how many replica would run, and you can also come up with something called HPAs and VPAs. Even we have KDA, which is Kubernetes event driven scaling. You can scale your number of pods of a particular application based on the events. For example, if you're running Kafka or running anything like RabbitMQ or message brokers, if the events getting increased over in this particular like let's say message broker or these kind of application caching, if you're using, if the number of events grows, you can also increase the you can say the number of instances of the containers which will support that kind of traffic, and you can also vertically you can also scale the application. So when I scaling, there are two types of scaling normally seen. One is the horizontal and one is the vertical. Under horizontal, we increase the number of instances of the containers or anything in a horizontal way. I mean, number of adding of a particular system itself. For example, one container is there, you create another container to support that kind of traffic. But when we say vertical, you increase the resources like individual memory or individual CPU. You increase or decrease. That is called vertical scaling. So all these things you have in Kubernetes, you have a nice framework where you have something called a component which is called controller managers. Under controller manager, you have various controllers. You have replica set controllers. You have deployment controllers for any object that you see on Kubernetes, whether it is services or deployment or stateful set. You have controller written for managing the lifecycle of all those objects on Kubernetes, and that's how the power of orchestration comes in. You might have seen that how the let's say a deployment is running. Deployment is just a you can say a wrapper, and under deployment we have pods where your actual container workloads are running. You can say application pods are running. The moment you see the application is running over there, you will see various things are automated. For example, the application goes off, and if it is out of memory or anything called crash loop back off or something is fishy on the application part, you will see that there is a certain structure in Kubernetes that it actually retries to restarts the pods, and in that way it tries to self heal the containers or pods which are running in behind. You can have a number of things. You can write your own operator. You can write your own custom resource definitions under those operator, and you can write a number of self-healing capabilities which Kubernetes will support. And also we have nice toolings and CNCF projects which help you to keep the workload which is running in a Kubernetes healthy. And there are self-remedial steps as well. As I mentioned, crash loop back off, all these kind of events, Kubernetes is able to heal itself. So these are the orchestration techniques which actually Kubernetes is using in behind. And we have a couple of the tools here. For example, Docker Compose was there when the container became really heavy, but I mean, when you see the number of pods are there, the Kubernetes as a framework do a very nice job while having this orchestration automated, and also having a full life cycle management automatically using Kubernetes. And coming to why it is important, then it give you scalability. Scalability means how much, let's say, your today there might be a requirement of these many compute, or this would be the expected traffic or if application, and how many features it is supporting. But tomorrow those can increase. I mean, what kind of let's say your application is now having a surge traffic, a spike in a traffic, and it is commonly used by common masses. So It will also keep things scalable in that case. For example, we have various, take an example of cloud-based Kubernetes, for example, EKS. When EKS as a cluster is seen, you will see that it is able to scale even from the worker nodes level and also at the pod level. If, for example, you have given a particular a number of like minimum and maximum pods under an HPA, and you mentioned that these would be the minimum number of pods, and when your traffic is at a certain level and it crosses certain threshold, for example, average CPU or average memory, you can program it to scale it to n number of pods, whichever is your threshold. After it reaches a certain threshold, something called Carpenter is also there on EKS, which will give you to scale your EKS as part of the worker nodes. For example, initially you may have a 10 number of nodes supporting in EKS, but you can mention like with help of your something called cluster autoscaler. Even other public cloud supports them, but in EKS we know about this is a native tool called Carpenter, and it scales your n number of nodes as well. While doing it, so you can see that it at the level of the nodes also it is able to support that kind of traffic by scaling itself. And even the Carpenter is intelligently written in a way that if it is not required, it can also can give you cost saving as well. If it is not required, it will go to the minimum number of nodes, which may be at the particular moment. If these many nodes can accommodate these number of pods, so it will only have those number of pods or those number of nodes at that very moment, and it can save you lots of lots and lots of cost there. We have seen various times in cloud. I mean, as part of my experience as well, that the scaling becomes really fishy when it has gone to a certain number of nodes. If it is not required, I have seen various times that it is not able to come down. For example, all the resources which are used, these are underutilized. But it is now, I mean, with the recent updates, I have massively seen that it is now getting supported, and even Carpenter works really well. Even in Azure is also using it called Cluster Autoscaler, and in the backend and the hood, they are using Carpenter. So these are some intelligently written tools which is written by open source communities, and this is all because of even the whole Kubernetes as a framework, or you can say a orchestration tool. It is getting a massive support from the open source communities. They give you high availability, it give you lots and lots of automation, as I already mentioned, and you have resilience in cloud native environments as well. Any contingency or such kind of broke scenarios can also be saved a lot of time by using the container orchestration frameworks. Example is Kubernetes. So key players in orchestration, we know Kubernetes already there. Vanilla Kubernetes powered by kubeadm and open source. How we can run our vanilla Kubernetes also on on-prem servers using kubeadm. We have Docker Swarm already mentioned, but yeah, it is just used in with the purview of Docker, not Kubernetes here. But HashiCorp also provide. I mean, everybody knows that Terraform is powered by HashiCorp, and Nomad is also such a tool. ECS is there, but we can say ECS is also orchestration platform. Kubernetes is something else. When we say ECS is the Elastic Container Service, and you can view the ECS as a service which just give you the number of containers scaling, and it can create a number of containers there, but you won't be finding those kind of things. For example, ingress and egress. You can view it as just for a platform where your containers run, but it is not that very much intelligent here as an orchestration tool, but can really help you in some number of scenarios where you, for example, let's say you don't have a bandwidth, you don't have that kind of a technical support in your organization, where you don't have a DevOps team with you to have Kubernetes and to maintain Kubernetes. It is another set of a challenging task, because you require somebody who is good with the administration of a cluster called Kubernetes, and you require various things. You even require nice frameworks, for example, Argo CD if you want GitOps, if you want automation. So lots of engineering efforts needs to be played there. But I have helped the organization to implement their containers and their workload using a platform called ECS. Even we have container apps in Azure, just like ECS. But you need to mention all the other things. For example, Ingress won't be here. ECS won't be giving you that kind of thing for an Ingress. So you don't have something called Ingress controller here, and which you can do with ECS. You have to rope in other things like ALB and LBs, all these kind of services to implement something called ECS. OpenShift is another, you can say, wrapper over Kubernetes. OpenShift is paid services provided by Red Hat, and this is one of the nice tool. I mean, but under the hood, it is same. It is running Kubernetes. So yes, the industry standard, we have architecture components. I think in the first session, you might have also discussed about the components, architecture, how master nodes and API servers and all those kind of components can run really uh, in a very easy manner, and you will see various advantages over there because you have a master slave architecture kind of a architecture here where it provides you resilience as well as previously covered. It gives you uh, a whole scenario where you have various things, uh, structured layout, and you also have package managers, for example, Helm, and all those kind of open source tools that really gives you a nice picture around it, and all the things become really easy, and it has a nice documentation. The Kubernetes supports a nice, very varied and also very in-depth documentation that I've seen so far. Everything is kind of documented, and we have even contributions as well from open source, which every day there are lots and lots of contributions for this documentations, and we see updates as well from the community. Okay, so I'll cover up architecture about Kubernetes and how it schedules, deploys, and manages a workload using a Kubernetes workflow. Give you a nice picture around it, how it does. So alternatives to Kubernetes, we have Docker Swarm Nomad. Okay, this is already covered. Then modern trends, multi-cloud, AI-driven orchestration, GitOps, and KubeVirt. KubeVirt is something called, for example, you use Kubernetes to orchestrate. Lastly, containers, pods. KubeVirt is a framework which give you an ability to manage VMs. For example, you remove pods. You can imagine how different VMs are running or managed by something called orchestration of Kubernetes. But in KubeVirt, will give you facilities to manage and orchestrate the VMs with KubeVirt. Coming to multi-cloud approach, various times, it happens. uh, for example, let's say in KSA region, mainly Saudi, you will not find AWS as a data center there. You only have even Azure isn't there in the KSA region. You will see that they only support GCP right now. One of the data center with AWS is in the pipeline, but still it is not there. For example, the company who is only operating with one of the cloud, you will see they will have various problems when they scale and when they see that their reach is going to the other countries, and they only have infrastructure support or their engineering team who are good with only one kind of cloud. In that situation, I've seen organization, they really suffer a lot if their architecture, if their application is not platform agnostic. It so the thing is that in cloud native approach, you try to keep it multi-cloud and even hybrid. You can support on-prem things on your infrastructure part, and you can do things with having various things in multi-cloud. When we say multi-cloud, you can have your infrastructure which is radically associated. Like for one of the component, you can have Azure. For another component, you can have let's say AWS uh, uh, cloud, and you can have GCP as well. We see that a few of the services from the other clouds has championed. For example, the data services from the GCP are quite well. You can use BigQuery services and other AI services from GCP. Those are really good. And you can have the Kubernetes tools like EKS and all these kind of tools which are really good in by the AWS. In this way, you can create a nice infrastructure, and this is what the modern trend in orchestration. You don't keep yourself vendor lock-in with one of the clouds, and you keep yourself really easy going with if you have a multi-cloud approach. When you go with multi-cloud, you basically are platform agnostic. When you bring in the tools like Terraform and all, because Terraform supports various clouds, it can even support uh, DigitalOcean and all those kind of things, and we have a nice support for this. Coming to GitOps, Argo CD, already mentioned. Okay, when we say when we talked about container orchestration, when I was mentioning Docker Swarm is also an orchestration platform, but things like RBAC, port security policies, nowadays port security admissions, we have network policies, we have service mesh. Network policies is also one of the very important thing when we consider DevSecOps. Today, Kubernetes security has become, I mean, the thing of the future, and it is really trendy. People are adopting Kubernetes. I think 90% of the workload, if you see today, are running on Kubernetes. uh, 90% is kind of an overcommitment, but yeah, 60 to 70%, yes. Because still today people don't find, or they don't have bandwidth to support Kubernetes. But yeah, I mean, it won't be wrong enough to say that 60 to 70% workloads, we see that few workloads are running on Kubernetes. When in production level, you have some platform called Kubernetes, and you are running your workload on such kind of an orchestration tool, you will see that the network policies become really a thing of that is really required. You Because you want to have a certain order and also certain security framework within your Kubernetes. When you want certain kind of a workload, talk to a certain kind of and other workloads in a service mesh architecture. Service mesh is a different thing, but when we come to network policies, we want to tell a particular resource that you are allowed to talk to this particular resource, and all the other you can deny the traffic. This is, for example, you can see that okay, you have a database containers, database pods as a stateful set, and you have a deployment where your application pods are there. So you only want your database pods to talk to the you can say the backend application or backend pods written in Python or in whichever language it could be or framework it could be. But you want basically these two to talk to each other, and otherwise you can deny all the traffic. So it's just an example for having a scenario like this where you would actually require network policies, and we have pod security policies. You will see in DevSecOps various things, but one thing is very, very privileged here to talk about, which is one thing to have always a zero trust security. Zero trust means you keep the privileges really, really low. You keep the privileges very least when you start off. For example, let's say um, the scenario like when you have a pod and it is not running as a root, and you will see when it is not running as a root, various things it can't do. But if it has an escalated privilege of a pod, it is running as a root, you will see it can create a scenarios like container escapes, and it's a nightmare. We have recently seen that Ingress Nightmare and those kind of things, which has came in, and very new Wiz has championed in container securities, and they have also come up with these CVEs, particularly from the Ingress from the Nginx community. And the issue was basically that it has an admission controller, and we have admission review requests, which are basically unauthenticated and unauthorized checks, and the request being going to the admission controller, and over there it can create a scenarios of remote code executions. So basically these are all included in these, and you will see if you don't have orchestration frameworks, you won't be able to implement these kind of policies and implement these kind of frameworks. RBAC is your role-based access control, where you create RBAC policies, you create roles, and then you create the bindings. If it is a uh, cluster, if you require something from the cluster role bindings, or you want a role binding particularly for a few of the resources which are namespace code, you can have roles, and then you can create a binding, and then you can implement that RBAC on a particular resource, so that some users have access to particular resources, but you won't be seeing that the some user is having full blown access on a Kubernetes cluster. So you have role based access control, that this is the role of this particular user. If it is a backend developer, what kind of resources you want him to see in the Kubernetes cluster, you can mention using these two techniques, like a role binding or role, and a cluster role or a cluster role binding. If it is a cluster level, when I say, okay, let clear this out, that what is a cluster level or the namespace level resources. When we say the objects which are cluster wide, for example, the persistent volumes or namespaces or services. So these kind of objects which have the cluster wide level, we say that it's a cluster wide. And if it is a namespace level resources, which is, for example, deployment, or which can be scoped in a namespace isolation within this, you can see these are basically called the um, namespace scoped, or not a cluster wide scope of the resources. So we have a nice framework here with RBAC, mentioning the security. So orchestration give you security considerations. This is one of the very major point to be you can, I mean, jot down, or you can have serious uh, I mean consideration for this thing, that the orchestration provides you security considerations within the orchestration platform like Kubernetes and OpenShift and other things. So best practices, we have scaling strategies. What actually orchestration provide you? One is scaling strategies, as I mentioned, KEDA, HPA, VPA. The scaling strategies that you get with container orchestration. You have resource optimization. You can optimize your resources based on the scalars like KEDA. You can optimize your resources. You can use the implementation of, for example, uh, VPAs, which can also tune your limits and memory of your particular deployment or a stateful set object. And you will see if it is if one core of your CPU is not required, you will see it can go down, it can use less. And after, if your VPA is enabled on your cluster, you will see after a certain moment when the traffic is not that much, you will see the VPA has actually quoted lesser value of CPU or a memory, and that can actually save a lot of cost there. You have better monitoring. For example, if you have a orchestration, you this is something related to monitoring. If you're using some external tool, for example, CloudWatch or Azure Monitor or these kind of things, which directly is giving you a monitoring framework also with when you have some orchestration in place. Definitely, you need to bring some other tools like Prometheus, Grafana, or these kind of stack, which is readily available as a uh, help and support using some the continuous you can say basically the orchestration tool like Kubernetes, and you have a nice support by the open source community as well. And we have a number of resources. You can even have New Relic or Jagger or Open Telemetry or these kind of tools to see the better monitoring of all the workload which are running. We have service mesh architecture as well. When you have particular services and you want that which particular service and which particular service to talk to each other, and which should not which should not actually talk to each other, and you have different versions of your application. How much traffic you need to send to this version of an application, let's say V1, and how much, let's say 80% you want to have it on V1 and 20% you want to have it on V2. So these kind of things can be used with service mesh. For example, Istio and Linkerd, all these kind of frameworks are available, and you can only implement it if you have some orchestration with you. With pure Docker Compose, you won't be able to see this. Future of container orchestration and industry adoption trends. Uh, Container orchestration, definitely. If you're on Docker, you need to have something with its orchestration. If you have n number of Docker containers and you only think that you have a host and you only run Docker container over it and create an Nginx to route the traffic to this, it can do the work for a particular moment, or maybe 1 year or 2 year, but when your application scale, when your number of containers will grow in terms of your the you can say the traffic or your application, definitely the container will increase, and then you will see that it requires an orchestration, which becomes a natural thing to rope in. Industry adoption trends, industry has really adopted this, and then uh, okay. So let's understand how Kubernetes orchestrates a containerized application using master worker architecture. I mean, if you attended the first session, it should have been covered, but let's have a recap of what we learned in that, and how actually the orchestration mechanism in Kubernetes actually works. We have control plane that manages the cluster state and scheduling. We have an API server which actually facilitates the communication between components. And also API server is also an authentication server, basically, which authenticates your request when you do kube. You write something called kubectl get ports and all those kind of commands. It actually makes an API call to your Kubernetes cluster to a API server. It authenticates whether you have certain credentials or not with you, and it's basically a kube config file which resides in your let's say a remote maybe your own system where your kube config resides, and taking that file and it authenticates between there are some keys. It's a similar concept of how we do an SSH to a remote machine. That's also authentication is going, and the back and forth, and here also authentication goes. You have etcd as a store the cluster configuration state. Anything that you do on your Kubernetes cluster, it gets written on a database called etcd, which is on BoldDB. BoldDB is inside. I mean, it's a kind of a database that is running powering your etcd. Then there is a scheduler that which actually assigns the workloads to worker nodes. We can, I mean, I'll better explain you in the with the diagram. And we have controller managers, as I mentioned, that we have various controller managers which actually manages the life cycle of all the objects created and supported in the Kubernetes. We have built-in objects, for example, deployment stateful sets. We have HPAs and VPAs. I mean, VPAs is not uh, naturally you will get with anything, but yeah, HPA it does support. We have replica sets. We have so the moment you create deployment, you have replica set also created if it has certain number of replicas. Even if one replica gets created of a deployment, then also replica set is created, and it tries to maintain. Basically, let's say if you create a deployment and you say that it has to have two replicas, and you go to the cluster and you say that kubectl delete pod, and you mention that name of a pod. You will see that it had to have two pods, but you deleted one. You will see that it will again recreate that, because your replica set had mentioned that it needs two replicas to run for this deployment. So it's how it works. You have worker nodes. They run actually the containers application using Kubernetes and kubeproxy. Your worker nodes have a CRI which is called container runtime. For example, container D or Docker. If you have as a container runtime, worker nodes is the main node in your cluster which actually runs the pods. You have kubelet and kubeproxy there. Kubeproxy is a kind of a proxy service which actually give you it basically helps you to direct traffic from a virtual service Kubernetes to the backend pods. It uses the labels there on your Kubernetes services. Whichever you in the manifest you mentioned that which kind of label, it matches the label basically. So there is a label matching over here, and that's how a service know where to forward the traffic if it reaches on a service from the ingress, and how to reach to a pod. Then pods is the smallest deployable units encapsulating containers. So as I said, pod is a wrapper over your containers, and you encapsulate a container with the help of a pod. So you can see the how it works. Basically, this is a uh, cloud version of your Kubernetes, where you have cloud provider APIs and you have cloud controller managers, and you will see you have CM, which is called controller manager, and you have cloud controller manager. You have an API server, you have a scheduler, and you have an etcd in the control plane. So these five components, basically in vanilla Kubernetes, you will not see cloud controller managers. Why there is an add-on on cloud controller manager is because you have from the cloud, you have association. For example, you do anything, you type kubectl hyphen f, and there is some manifest, and you apply it on your Kubernetes cluster. It basically makes an API call to your provider, your cloud provider, which has actually provisioned a Kubernetes cluster for you. For example, if you want to create a service of type load balancer, it actually creates a layer 4 load balancer on cloud. So this is how, I mean, there is a back and forth API call between your cloud and the Kubernetes that is there. So that's why there is another component called Cloud Controller Manager here, which actually talks to the API provider as it is annotated in the diagram. Then you see that you have various nodes, and you have kubelet and kubeproxy. Kubelet is kind of a systemd process, which is very closely in sync with the kube API server of your master node. It basically gives you all the it gives the kube API server all the required metrics on all of the worker nodes that is required. For example, its health, and whether this node is available or not for scheduling a workload. And it gives you various other metrics, for example, CPU, memory, everything that is collected by the kubelet. It also gives, basically it gives a status to KVP server, which is what is the status of this node, particularly at this very moment. And if any requests come to the scheduler to create a pod or placing a pod, it gives this request to directly to KVP server. The scheduler is a kind of a controller. You can see it's a basically bunch of APIs which calls the API server and collects the matrix from kubelet. It sees that okay, this is the app node where I should keep the. This is just a placer of the pods of workload on the node. So it makes basically tells the KubeAPI server where to put the pod for creation. It makes a call to kubelet. Kubelet makes a call to CRI to create a pod. Basically, CRI is container runtime interface. For example, Docker or Container D, it will give you a request to the CRI. It will create a container or a pod with using that CRI. And after the pod gets created, then you have various calls to CNI. For example, the CNI plugin, if you're using Cilium or Calico or Flannel, whichever you are having. And Azure provides their own CNI. Azure CNI, we have mm, EKS provided CNI as well, but you can have your own if you want. I mean, if you want to have eBPF, then you can use Cilium. It has a nice packet visibility. You can use those. These are all open source. So basically, you have kubelet, kubeproxy, scheduler, controller plane, and node. So this is how all orchestration scenario goes with Kubernetes, and that's how it powers. It gives you that kind of a platform where you can orchestrate your workloads uh, if you have n number of pods and powering your application, whether in namespace or we have multi-tenancy also in Kubernetes. So then I mean, this is a basic content orchestration framework of any orchestration layer. Also, you can say what is orchestration layer. So this is the orchestration layer where you have all these components. They are working together. They are communicating to each other, and then giving you a nice framework, a nice UI. Also, you can say, and that's how it works. So that was all about your orchestration, and I'm open to any question if it is uh, for this discussion.
Yeah, feel free to ask any questions if anyone have. Yeah, fair enough. Like we will also share this PPD in our group also. So if someone have, you can also reach out to him, or we can connect with him.
Yeah, I'll share that if it is required. And if somebody has any question right now, or maybe somebody wants to reach me out, I'm on LinkedIn. Uh, yeah, we are on, and anybody can reach me for any kind of a support if it is there related to Kubernetes or any technical challenge if they're facing for this or anything for any practical thing. If you want, you can. I'm available. Yeah.
Yeah, it was a very insightful session,
Yeah. Thanks.
and thank you for coming.
Yeah. Sure.
Thank you, everyone. Hope to see you all in the third session of KCNA Bootcamp by CNCG Gandhi. Yeah, thank you. Bye, everyone.
Thanks. Bye.